audible? Good morning, everyone. Am I audible? Someone can
Yes,
respond.
sir.
Okay, in our last lecture, we have seen the shadow paging. It's one type of database recovery. It creates the current copy as well as one old copy, and old copy refers shadow page table refers the same thing. And after we have seen the concurrency control, it means whenever we have a multiple parallel transaction in execution, it may lead a problem: lost update, dirty read, and incorrect retrieval. Then we have seen in concurrency control uh, lock mechanism, which is associated with the data item to lock a variable. There are mainly two types of lock: exclusive and shared. In exclusive, data item can be both read as well as the write operation. In a shared lock, can be only read operation. And we have seen the log compatibility matrix. Based on that compatibility matrix, we have seen the one example. Now today we are going to discuss pitfalls of concurrence control and two-phase locking mechanism, which is very most ahem. So just wait for minutes. Let me save this screen. Is it visible? You can respond in chat also. Now when we have a multiple transaction, yes, when we have a concurrency in a transaction, at that time some pitfalls are there. So pitfalls of lock-based protocol. What will be the situation? Let's consider the following schedule: T and T4. In a T3, understand this schedule very well, because this concept is very important and it leads to the next topic. So it is in sync. As you know, lock X it means exclusive lock, and lock S it means shared lock. Exclusive mode it means read and write both. Shared lock it means only read. So in a T3 transaction, first lock X is on data item B. So once we get the lock on that data item, other transaction cannot get that lock until previous one release that lock. It means T4 will wait until T3 release the lock X on B. So here lock X B, read B, B minus 50 and write B. There is no unlock X of B. But after that, T4 gets the lock SA. Now on data item A, there is no lock, so T4 gets this lock, because data item are different. Here in a T3 it is B, here in a T4 it's A. Then read A, and then T4 request for lock SB. T4 lock SB. It means it request for the said lock on data item B, but data item B is held by the T3 transaction on a exclusive mode. So until T3 release that exclusive lock on data item B, T4 has to wait. It means T4 को wait करना पड़ेगा. Similar way, lock X A, T3 request for lock X on A, which is held by T4. जब तक T4 रिलीज नहीं करेगा तब तक T3 को वेट करना पड़ेगा. It means T3 waits for T4 and T4 waits for T3. So neither T3 nor T4 can make the progress because both are dependent on each other. So this situation is known as the deadlock. Neither T3 nor T4 can make the progress. So let's see, neither T3 nor T4 can make progress because lock X on data item B causes T4 to wait for T3 as until release its lock on B. जब तक T3 रिलीज नहीं करेगा तब तक T4 को वेट करना पड़ेगा ऑन अ डेटा आइटम B. सिमिलर वे lock X A causes T3 to wait. T3 को वेट करना पड़ेगा जब तक T4 डेटा आइटम A को अनलॉक ना करे, रिलीज ना करे. And this situation is known as the deadlock. The last topic of this unit is the deadlock. You need to learn this topic deadlock in a detail. How we can identify the deadlock. If you understood very well this transaction, then you are able to understand this concept deadlock. Now, how we can handle T3 and T4? So to handle a deadlock, one of T3 or T4, either T3 or T4 must be rolled back and its lock must be released. That is by using mutual understanding, mutual exclusion, or we can say that by using a lock manager. T3 और T4 दोनों में से एक रिक्वेस्ट वापस ले ले, रोल बैक कर ले, तो प्रोग्रेस हो सकती है. Either T3 or T4 will be rolled back, then lock will be released and T3 or T4 can make the progresses. Now second one, if T3 is going on after the T4 request for lock S and A and read A lock S B. यहाँ पे B की वेट कर रहा है T4. जब तक T3 रिलीज नहीं करेगा, till that time T4 waits for the data item B. But some other transaction like T5, T6 request for the on data item B and gets the lock. T4 को नहीं मिल रहा है लेकिन अदर ट्रांजेक्शन आए, शेयर्ड लॉक की रिक्वेस्ट कर रहे हैं और उसको शेयर्ड लॉक मिल गया और T4 को फिर से रोल बैक करना पड़ेगा, वेट करना पड़ेगा. सपोज T6 आया, T6 ने रिक्वेस्ट की, ग्रांट मिल गई. अगेन T4 हैज टू वेट. अगेन T7 केम and grant the request. Again T4 has to wait, and this wait forever situation is known as the starvation situation. Let's see. In most of locking system, deadlock occurs and starvation is also possible. There are less chances of starvation, but if concurrency control manager design it badly, then starvation may happen. अगर मैनेजर उसको शेड्यूल प्रॉपर नहीं कर रहा है, बेडली डिजाइन कर रहा है, ट्रांजैक्शन शेड्यूल बेडली डिजाइन कर रहा है, तो स्टारवेशन होने की पॉसिबिलिटी है. Starvation is also possible if the concurrency control manager is badly designed. For example, a transaction may be waiting for X lock. Either T3 or T4 or any transaction is waiting for X lock on any particular item, while, remember this thing, while a sequence of other transaction request for that and granted the S lock on the same item, then that transaction has to wait repeatedly और सेम ट्रांजेक्शन इज रिपीटेडली रोल्ड बैक ड्यू टू दी डेडलॉक, रिपीटेडली रोल बैक होगा तो उसका चांस ही नहीं आएगा, दैट इज नोन एज द स्टारवेशन. Now how we can manage the starvation? There are 2 points. First point, there is no other transaction holding a lock that arises certain type of conflicts. Whenever we find any conflicts, इससे ट्रांजेक्शन कोई भी लोग होल्ड ही नहीं कर रहे, तो स्टारवेशन अवॉइड हो सकता है. और there is no other transaction who requested a lock before any other transaction and is still waiting to acquire a lock. Who requested a lock before any other transaction and is still waiting to acquire a lock, then we can manage the starvation. So we can avoid this starvation. Next is the two-phase locking protocol. Make sure all of you, there are two different theory in this unit. One is two-phase locking protocol and one is two-phase commit protocol. In a two-phase commit protocol, prepare phase and commit phase. Already we have seen that theory. Now, today we are going to discuss two-phase locking protocol. In this two-phase locking protocol, there are mainly two phases. Name suggests its meaning. First phase is growing phase and second one is the shrinking phase. As you know, the T begin and T end as per the time. आपका टाइम यहाँ से ट्रांजेक्शन स्टार्ट होगा और यहाँ पे एंड होगा. Suppose first phase in a growing phase. So in a growing phase, any transaction may obtain only the locks. It means whenever we are in a growing phase, only transaction may get the locks. Transaction lock लगा सकते हैं, रिलीज नहीं कर सकते. ट्रांजेक्शन कैन नॉट रिलीज द लॉक इन ग्रोइंग फेज. ट्रांजेक्शन में ऑब्टेन द लॉक्स. So transaction may not release any locks. So it means growing phase start from the beginning. Whenever transaction starts, the growing phase first start to obtain the locks, and at the end, or maybe at some point, it will start this shrinking phase. It means it's a reverse of growing phase. In a growing phase, we may obtain the locks. In a shrinking phase, we may release the locks, but we cannot get the locks. So in a shrinking phase, transaction may release the locks, but transaction may not obtain the locks. So this is the shrinking phase. And to ensure the serialized transaction based on lock point. Lock point means where a transaction acquired its final lock. Suppose maybe lock point is here, maybe lock point is here, maybe here. Because when growing phase start, it may obtain the locks, and when in a growing phase any transaction acquired last लॉक, फाइनल लॉक, उसके बाद कोई भी लॉक की रिक्वेस्ट नहीं आएगी, तो उस पॉइंट को लॉक पॉइंट बोलेंगे. आफ्टर लॉक पॉइंट श्रिंकिंग फेज विल स्टार्ट. इन अ श्रिंकिंग फेज ओनली we can release the locks. We may not get any locks after the lock points in a shrinking phase. So it may be लॉक पॉइंट्स में भी यहाँ पे भी हो सकता है, लॉक पॉइंट्स यहाँ पे भी हो सकता है, मे बी यहाँ पे भी हो सकता है. Yeah. Now lock protocol conversation. It's a part of this thing. Remember this previous slide, growing phase and shrinking phase. Just one minute. And this theory asks two-phase locking protocol. You need to start from this growing phase, shrinking phase. Then with this conversation, I will tell you later on. First, let's understand, complete this theory. Yes, lock conversation are allowed in this phase. It means we we have a mechanism for upgrading and downgrading of the lock. Upgrading it means we can upgrade the lock mode from shared lock to exclusive lock. Upgrading it means shared lock only read the data item, and exclusive it means read and write. So from read to read write, it means shared lock to exclusive lock, then it is known as the upgrading, and downgrading it means from exclusive lock to shared lock. So this mechanism is known as the downgrading. Upgrading can take place in only the growing phase, whereas downgrading can take place only in a shrinking phase. So this is the log conversation, upgrading and downgrading. This is the part of this theory also. Growing phase, transaction receive log S, transaction receive log X, or transaction convert log S to log X. That is upgrading. It means it is similar to previous slide. In a growing phase, we may obtain the log. We may obtain the lock. It means either shared lock, exclusive lock, or upgrading shared to exclusive. Similar way in sinking phase, transaction release lock है, अगर transaction ने hold किया है exclusive lock तो release कर सकता है, और convert the downgrading. It means lock X to lock S. This conversion may possible in the growing and shrinking phase, which ensures the serializability. Now, in this part, we have a two types of two-phase lock. Two-phase lock, it has a two types. Strict two-phase locking protocol, and second one is the rigorous two-phase locking protocol. Let's see strict two-phase locking protocol. In a strict two-phase locking protocol, transaction can release all the shared locks after the lock point. It means after the lock point, he may release only the shared lock, not exclusive lock. He may release only shared locks, but we cannot release any exclusive lock until the transaction commits or aborts. जब तक ट्रांजेक्शन कमिट और अप्रोच नहीं होगा, तब तक हम सिर्फ शेयर्ड लॉक ही रिलीज कर सकेंगे, एक्सक्लूसिव लॉक नहीं. देन दैट टाइप इज नोन एज द स्ट्रिक्ट टू फेज लॉकिंग प्रोटोकॉल. It ensures that if the data is being modified by one transaction, then other transaction cannot read it until first transaction commits. That we have discussed earlier. Shared lock after the lock point, but cannot release any of the exclusive lock. वो modify कर रहा है. And already we have seen the conflict serializability and view serializability, so get better idea for this. Now in a rigorous, स्ट्रिक्ट में सिर्फ शेड लॉक ही अनलॉक हो सकता है, रिलीज हो सकता है. इट मीन्स रिगरस में दोनों होने चाहिए. सो इन अ रिगरस इट इज not allowed, transaction is not allowed to release any lock, any type of lock until it commits. जब तक वो कमिट नहीं करता है तब तक उसको एक्सक्लूसिव और शेड लॉक रिलीज करने की परमिशन नहीं है. Why? It's a very simple reason. Already we have seen the conflict serializability. At that time I told you, remember this theory, this one is the very most theory. Because while any one write operation is going on, if you are reading, if anyone is reading that data item, it may conflict. So same way, if transaction is going on and you release the shared or exclusive lock before it commits, it may change the data. जैसे और मैंने एग्जांपल आया था, दिया था मैंने, कौन सा एग्जाम वाला. अगर आप एग्जाम में आगे और पीछे वाले से कॉपी कर रहे हो, तो जब तक वो जो राइट ऑपरेशन कर रहा है जिसमें से आप कॉपी कर रहे हैं, वो जब तक कमिट नहीं करता, सबमिट करके नहीं जाता, तब तक आप नहीं बैठते। तो क्या होता है, आप उसमें से कॉपी करके सबमिट कर दिए, फिर उसने कुछ चेंज किया तो आपका ट्रांजेक्शन, आपका डेटाबेस इनकंसिस्टेंट होगा, आपका आंसर गलत हो जाएगा। जब तक वो कमिट नहीं करता है तब तक रिगरस में कोई भी लॉक अलाउड नहीं है ओपन करने के। So until any transaction commits, other transaction cannot acquire even said lock on any data item. It is already been used by active transaction. जब तक राइट ऑपरेशन हो रहा है तब तक इवन सेड लॉक को भी अलाउड नहीं है। दैट इज द कंसेप्ट ऑफ नथिंग बट ओनली कॉन्फ्लिक्ट सीरियलाइजेबिलिटी। कॉन्फ्लिक्ट की चार कंडीशन याद रह जाए तो बाकी की सब थियरी वैसे भी याद रह जाएगी। So this is the two-phase locking protocol. So up to this you need to write. Again, I am repeating the two-phase locking protocol. What you need to write? Yes, the two-phase locking protocol. First, you need to explain two-phase, growing phase, and shrinking phase. You may draw the diagram. You need to explain lock points, and then the upgrading and downgrading of this conversation, upgrading and downgrading. You can explain this in this upgrading and downgrading in short. Then two types of locking protocols, streak and recurrence. Up to this you need to write in a 7 to 8 marks. Yeah. If you have any query, then you can ask. Otherwise, we may start the next topic. Okay. Next is the multiple granularity. Multiple granularity. Uh, it's not too much exam point of view I am talking. It's not too much frequently asked question, but concept is known to you, as you know the tree structure in a database, sorry, in a data structure. Similar way, multiple granularity concept is that data items are represented in a tree like a structure. It has a parent as well as the child, as you know the tree structure. One root node is there. After that, it has some childs, and it has also a child like this tree structure like this. Here in the level 0, the database is there. After that, in the file 1 and file 2, file 3 are at level 1, but it is a child of database, and file 2 is having a 3 child, page 1, page 2, and page 3 at level 2. Again, page 2 is divided into a record 1 and record 2 at a level 3, and record 1 is divided into field 1 and field 2. Now, if we apply any lock mechanism on parent node, either shared lock or exclusive lock, then automatically all its children are locked. If a lock is acquired on parent node, then automatically all its children are locked. This is the main key line of this theory. If you remember this thing, then you are able to write entire theory if they ask in exam. Again, I am repeating. If a lock is acquired on a parent node, सपोज डेटाबेस के ऊपर ये लेवल 0 डेटाबेस के ऊपर हमने लॉक लगा दिया, देन ऑटोमेटिकली ऑल इट्स चिल्ड्रन आर लॉक. Who will be the children of database? File 1, file 2, and file 3. Now my question is to all. My question is to all. You need to give the answer in a chat. Record 1. Here it is at level 3. Record 1 will be locked or not. If I am applying a lock on a database, then my question is that record 1 will be locked or not locked. You need to give the answer in the locked or not locked? Type your answer into a chat. Again, I am repeating. If a lock is acquired on parent node, then automatically all its children are locked. If I am applying a lock on a database parent node, then my question is record 1 will be locked or not? Everyone needs to give the answer in a chat. Am I audible? Someone can respond. Yes. If I am audible, then please give the answer of this question. Okay. પેરેન્ટ નોટને લોક લગાવો તો ચાઇલ્ડ લોક થઈ જાય ઓટોમેટિકલી. લાઇન સેઝ લાઈક ધીસ. તો મારો ક્વેશ્ચન ડેટાબેઝ છે એ તમારો પેરેન્ટ નોડ છે એને હું લોક લગાવું તો રેકોર્ડ 1 જે છે નોડ નીચે લોક થાય કે ન થાય? તમારે આન્સર દેવાનો છે લોક ઓર નોટ લોક ઇન અ ચેટ. સાચો ખોટો એટલીસ્ટ તમારી સમજણ પ્રમાણે આન્સર આપો એટલે મને ખબર પડે, પછી હું એક્સપ્લેન કરીશ. નહીં આવડે તો ડોન્ટ વરી. I got the two answer from Umesh and Syam. Out of 53 students, I think only few students are present here. Should I give attendance to only those students? Okay, I want one volunteer who can justify this answer after 1 or 2 minutes. Be ready for that. If you are able to give this answer, then this theory is very easy to everyone. मोस्ट ऑफ आपने आंसर सबने लॉक दिया है. अगर कोई बंदा ये लॉक क्यों लगेगा उसका आंसर जस्टिफाई कर देगा, उसका मतलब ये थियरी आपको पता चल गई. इस थियरी में ज्यादा कुछ है नहीं. इट्स अ वेरी सिंपल थिंग. Okay, only 20 students out of 53 students. Okay, it's fine. Can anyone justify? This is the bad habit of your class. Okay, definitely this answer is correct because whenever we are applying a lock on the database at a parent node, at a root node, its child automatically locked. It means file 1, file 2 and file 3 will be locked. But file 2, if file 2 is locked, automatically page 1, page 2, page 3 will be locked. Means all these sub-children will be locked. That's it. If any transaction request lock on any child, अब हम रिवर्स कर रहे हैं. पहले हमने क्या बोला कि रूट नोड पे लॉक लगाएंगे तो चाइल्ड लॉक होगा कि नहीं. मैंने डायरेक्टली आपको क्वेश्चन पूछ लिया कि डेटाबेस पे लॉक हम लगाएंगे तो रिकॉर्ड 1 लॉक होगा कि नहीं होगा। आपने बोला कि होगा। अब मैं रिवर्स चेक कर रहा हूँ, अगर मुझे रिकॉर्ड 2 पे लॉक लगाना है तो फर्स्ट आई नीड टू चेक व्हाट आई नीड टू चेक, रिकॉर्ड 2 लॉक है कि अनलॉक, वो चेक करना पड़ेगा। सपोज अनलॉक है, रिकॉर्ड 2 पे कोई लॉक नहीं है, तो फिर मुझे क्या देखना पड़ेगा, उसके पेरेंट लॉक है कि नहीं, पेज 2 लॉक है कि नहीं, फाइल 2 लॉक है कि नहीं, डेटाबेस लॉक है कि नहीं, वो चेक करना पड़ेगा। दैट इज द सिंपल थिंग that I am trying to explain you from you guys. If any transaction requests a lock on any child, then compiler checks whether a lock on any parent has not been given. अगर रिकॉर्ड 2 पे मैं लॉक लगाना चाहता हूँ तो उसके पेरेंट्स को लॉक नहीं लगाना, वो चेक करना पड़ेगा। सेम एग्जांपल आई हैव गिवन हियर, इफ पेज 2 हैज बीन लॉक्ड, if page 2 has been logged by any transaction, any all its children, page 2 के children, record 1, record 2, field 1, field 2 will be logged, चारों लॉक हो जाएगा। now at the same time, if other transaction request a lock on a record 2, if other transaction request a lock on a record 2, तो फिर हमें क्या चेक करना पड़ेगा, रिकॉर्ड 2 के पेरेंट पेज 2 लॉक है कि नहीं, तो पेज 2 तो यहाँ पे प्रीवियस पॉइंट पे हमने लॉक किया, सो देन लॉक विल नॉट बी ग्रांटेड एज इट्स पेरेंट पेज 2 has been locked by some other transaction. This is the multiple granularity. Next, graph based protocol. So mathematically you know the graph, some vertices, some edges, and already we have seen the testing for serializability, graph-based protocol. Similar way, it is the alternative of two-phase locking graph-based protocol. In that, we have a set D in which D1, D2, and DH are all up to Dn data items. If Di tends to Dj, then any transaction accessing both DI and DJ must access DI before accessing DJ. It means DI to DJ जा रहा है तो पहले DI access होगा फिर DJ access होगा, ठीक है। For that, set D may now be viewed as a directed acyclic graph. It is also called a database graph. So one type of tree protocol, simple ग्राफ प्रोटोकॉल भी हम बोल सकते हैं, और डायरेक्टेड ग्राफ असाइक्लिक ग्राफ भी बोल सकते हैं। इट मीन्स डी के अंदर जो भी डेटा आइटम्स दिए हैं D1, D2, D3, सो वी नीड टू ड्रॉ फ्रॉम DI to DJ, DI is accessing or not, like it's similar to tree protocol जो हमने मल्टीपल ग्रेन्युलरिटी में सीखा। सिमिलर वे ए बी सी यहाँ पे डेटा आइटम्स दिए, ठीक है। सो similar method we can apply. Only exclusive locks are allowed. So first lock by TI may be on any data item. Subsequently, that data item Q can be locked by TI only if the parent of Q is currently locked by TI. फर्स्ट हमने टीआई को लॉक किया है और ऑन एनी डेटा आइटम, ट्रांजेक्शन टीआई के थ्रू एनी डेटा आइटम को लॉक किया है, then subsequently any data item Q can be locked by TI only if the parent of Q is currently locked by that TI transaction. Similar concept we have seen in many multiple granularity. डेटाबेस और रिकॉर्ड 1, डेटाबेस पे जिसने लॉक लगाया है वो बाय डिफॉल्ट चाइल्ड को लगेगा ऑटोमेटिकली। तो सीआई ट्रांजैक्शन ने लगाया है तो डेटा आइटम सब्सिक्वेंटली उसके चाइल्ड हो, उसको ट्रांजैक्शन टीआई ने ही लॉक किया होगा, एंड डेटा आइटम में बी अनलॉक एट एनी टाइम एंड अनलॉक में बी with the same transaction TI. Now, how we can record all these things? ये लोग इस डेटा आइटम पे ये ट्रांजेक्शन ने लगाया, ये लोग इस ट्रांजेक्शन ने इस डेटा आइटम से रिलीज किया. हाउ वी कैन ट्रैक? as we are tracking everything. If you remember, we have seen one topic in this unit, log based recovery. At that time I have explained you log based means it will keep similar to history. Yes, we can say that similar to history. So from that we can check. So here locking mechanism, we can implementing a locking mechanism by one table, that is known as the lock table. So transaction send lock and unlock request to lock manager. There will be one manager who will manage everything and lock table. Everything it means कौन सी डेटा आइटम पे किस ट्रांजेक्शन ने लॉक लगाया है, कौन सा लॉक एक्सक्लूसिव है, सेड लॉक है, टीआई ने लगाया, टीजे ने लगाया, टी3 ने लगाया, वॉट एवर. और वेटिंग लिस्ट विल बी देयर विद द लॉक मैनेजर. जब तक लॉक मैनेजर रिस्पॉन्ड नहीं करेगा, नाउ यू कैन एक्सेस दैट ट्रांजेक्शन, sorry, now you can access that data item. At that time that transaction should wait for that data item. So all the transactions has to wait for the instruction of lock manager. Lock manager के response का wait करना पड़ेगा. So lock manager respond to the request either lock granted or wait message. If you are requesting for data item A, maybe in a SAID mode or maybe in a X mode. If it is available, then lock manager will send a message or respond to your request like lock granted. आपका lock grant हो गया. और सेम डेटा आइटम पे सपोज कोई ट्रांजेक्शन आपको कोई ट्रांजेक्शन लॉक मैनेजर को रिक्वेस्ट भेज रहा है, आई वांट दिस लॉक ऑन द सेम डेटा आइटम. तो ट्रांजेक्शन लॉक मैनेजर विल सेंड respond to that transaction, please wait, some another transaction is holding that data item. When it release, I will grant that lock and I will acknowledge to you. Yeah. So lock manager will do this thing by, as I told you, by maintaining one table that is known as the lock table. The lock manager keeps all the records of lock grants and pending requests in a lock table. Let's see this thing. Here one lock table is key one, dark rectangle, it means lock granted for the transaction after few times, and T2 request for that data item. Suppose I7 data item is here and T23 request for that item I7, and it will granted the lock, so it is granted. And if some other transaction, for example T24 is requesting I7, he has to wait. यहाँ पे लिखा ही है I23 T1 और after the T8 को ग्रांट मिला, T1 को पहले मिला, उसके बाद T8 को मिला. डायरेक्टेड साइन इट मीन्स पहले T1 ने रिक्वेस्ट भेजा, उसका काम खत्म हो गया, रिलीज कर दिया. फिर T8 ने क्यू में रिक्वेस्ट भेजा था तो T8 को ग्रांट मिला. Right now T8 is holding that I23 resource, I23 data item, and T2 send a request for the I23, but it is already held by the T8, so T2 has to wait. T2 को वेट करना पड़ेगा, इसलिए वो अभी क्यू में वेट कर रहा है. क्लियर? So this dark rectangle indicates granted locks, white indicates request, waiting request. New requests are listed in the queue from the bottom of the table. As you know the queue concept very well, so new request will be listed in a queue in the last. If transaction release a lock, it will check which transaction can be provided with that lock. किसका टर्न है किसको मिलेगा उसके हिसाब से लॉक ग्रांट होगा. So this is the log table. As you know, two types of locks, shared lock and exclusive lock. Similar way, we have a few more locks. Sometimes in our exam, they ask explain types of lock. At that time, you need to also write these three lock also. In addition to S and X lock modes, there are three additional lock with multiple granularity, that is intention shared lock, intention exclusive lock, and shared and intention exclusive lock. Shared lock is denoted by S, exclusive lock is denoted by X, intention shared lock denoted by the IS, intention shared lock. IX intention exclusive lock, and said and intention exclusive. Said it means S. Intention exclusive it means IX, that is 6. Now let's see. Now intention said lock, it indicates explicit locking at lower level of tree but only with said lock. Explicit locking at lower level ट्री में explicit lock हम लगा सकते हैं by only with the shade locks. ये आपको याद रखना पड़ेगा. And exclusive lock में simply same similar to previous one, explicit locking at lower level with exclusive or shade lock. Here it is the difference in exclusive or shade lock both. And in a shade and intention exclusive, subtree rooted by that node is locked explicitly in shade mode, and explicitly locking is being done at lower level with exclusive mode. It means both shade and exclusive mode. Subtree rooted by the node is locked explicitly in a shade mode. These three locks you need to remember. Intention locks allow a higher level node to be locked either in S or X mode without having checked all descendant nodes. मीन्स हायर लेवल को हम लॉक लगा सकते हैं शेड और एक्सक्लूसिव डिसेंडेंट नोड को चेक किए बिना. सो सिमिलर वे in a shared and exclusive mode we have a compatibility matrix. So again we added three lock here: intention shared, intention exclusive, and shared and intention exclusive. So here it is the compatibility matrix that you need to remember. IS intention shared, intention exclusive, shared and intensive exclusive, and exclusive. So there is one shortcut to remember this thing. First, in a first row, you can put 4 correct. It means these are compatible. IS compatible, IX compatible. True it means compatible. X it means not compatible. It means false. So पहले 4 column true, or in a first column 4 row true, and then diagonally 3 true. Diagonally 3 are true, and rest of are false. This is the shortcut to remember this thing. This is the shortcut to remember this thing. Simple. 4 true in a one first row, 4 true in a first column, including the first corner, and 3 diagonal, including first row. એટલે અહીંયા તમારું કર્સર રાખીને આમ ડ્રો કરો તો આમ 4 અને આમ 3, બાકી બધું ફોલ્સ. બાકી એકે કમ્પેટિબલ નથી. તો આ કમ્પેટિબિલિટી મેટ્રિક્સ અકોર્ડિંગ તમે મલ્ટિપલ ગ્રેન્યુલારિટી સ્કીમ એપ્લાય કરી શકો. સો whatever we have understood in a multiple granularity, पेरेंट्स नोड को आपने जो सही आंसर दिया, डेटाबेस को लॉक करेंगे तो record 1 automatically lock हो जाएगा. Similar way, lock compatibility matrix must be observed when any transaction रिक्वेस्ट फॉर लोड, तो हम पहले नोड को चेक करेंगे, उसके बाद कंपेटिबिलिटी मैट्रिक्स चेक करेंगे, देन we will see. So here it is the similar, and one example is given to you. Uh, we will see this multiple granularity locking system for this example in our next lecture. If you have any query, then you can ask.